This video is for my student Zaveri, who wants to understand the solution given to them. Now, Zaveri, it is very difficult for me to explain you this solution. However, I have my own solution, which is kind of different, but I hope you will understand and appreciate it. Right? So let's go through the solution. What I have also done is to explain you how to sketch these graphs. I've split this video into two parts. In the first part, I've already explained you how to find domain and range for this function, and here I will kind of sketch systematically and show you the graph of the given function, right? I'm not doing any calculations using the calculator at present, which you can do and then plot it on a graph paper. But first, let us understand how to sketch graph of trigonometric functions, especially when we are dealing with reciprocal trigonometric functions. Equation given to us is, well, the question before us is, sketch the graph of trigonometric function y equals to 5 cosecant minus 2 theta plus pi by 3 minus 2 on the interval 0 where theta is greater than equal to 0 and less than equals to 2 pi. So take note of the interval also. Okay, let's first understand the question itself. It says y equals to 5. We can write cosecant as reciprocal of sine, right? So I could write this as 5 over sine of, I always like to factor this part, so factoring minus 2, you get theta minus pi by 6, bracket close, minus 2, and we are going to solve this question within the interval 0 to 2 pi, right? So for this function, what is the time period? Now k value for us is minus 2, so the time period t will be 2 pi by, I should say k is 2, minus is reflections, forget about it, divide by 2, so the time period is pi for us. Now time period is 2. That clearly shows that within the period of 0 to 2 pi, we are expecting two waves. Right? So when you sketch this function, you have to sketch two waves, and let's highlight this. Okay. So when you take some points, you get only points for one set of waves using the key values. Repeat those points since sinusoidal functions are repeated. So sketch two waves. That's first part. Now let's try to sketch this function. So what I will do is I'll start with the sine itself and then show you how to sketch it. Let me just think about the scale first. Okay, I think that should be okay. So we'll start from here, and let's say that is my y-axis, correct? So I'll start with sketching with very light colors. So first I will sketch sine theta. So sine theta 2 pi is the rate. Okay, let's say this is sine theta for us, and we're talking about this scale, which is 0 to 2 pi, and this one is pi for us. So that is sine theta for us, correct? So let me write this as the green color. The first one we started with sine theta, correct? What do we need is sine minus 2 theta, right? So minus means this is going to be reflected horizontally, right? So it really gets reflected here, so horizontally. So basically the wave becomes kind of like this when we take minus of this. So that pi value, let me just take bigger value since we, so we will have a wave which gets reflected. Let me use another color here. So, okay, this is darker, so this is, I think, should work. So okay, so let me just sketch. These sketches are rough, but they are fairly good. So that means minus sine theta. Do you see that? So we reflect it on the vertical axis, horizontally. Do you see that? So reflection on y-axis gives us minus sine theta. Perfect. Now let us consider bringing it closer. That is to say, incorporating the k value. K means there are two waves in 2 pi, and as you know, time period is pi. So basically we will have two waves now within this period. Okay, so what really means that every point of this wave comes halfway, right? So this point will come halfway, this point will come halfway, so maximum will be kind of here, right? So we have one, and the minimum will be kind of here. So what we have here is a function like this. This is one wave, right? So another wave will again go like this, where, let me just draw a dotted line. It helps. These are for -1 and +1, right? So we'll have maximum here, 0 here, minimum here, there, right? So there you go. Okay, not bad. So anyway, so these are our two waves within a period of 0 to 2 pi which we considered, right? So this is I should say, I should have written here minus, but both are same things. Let me write this as sine of minus theta to be very precise. I did not reflect it on this axis, correct? Now this one is sine of minus 2 theta, is it okay? Minus 2 theta, that one minus inside, because we did horizontal reflection on y-axis, is that okay? So we get two waves. Time period is now pi, as you can see, correct, as expected. Next step is to move this wave pi by 6 to the right. So if you move pi by 6 to the right, let me write down the scale here now. So we have minus 2 pi here, right? This is pi by 2. So we have zeros at pi by 2, 3 pi by 2, pi and minus 2 pi, correct? Now we have to move the wave pi by 6 to the right. So this is pi, so this is pi by 3, and so pi by 6 will be, let's say, 3 more divisions, right? So each one is 1 pi by 6, 2 pi by 6, 3 pi by 6. So that much is pi by 6 for us. So we are moving each point by pi by 6. Do you see that? So that means the zeros will move to pi by 6, and these zeros will correspond to vertical asymptotes for cosecant x. Do you see that? So when I move this wave, let me use another light color. So this 0 will come here, correct? Maximum will move to pi by 6 to the right. Okay, now, okay, kind of like this, right? So every point is going to move pi by 6. But let's concentrate on zeros for this. So on zeros, now let's consider these zeros to be the vertical asymptotes for cosecant x, right? So what I will draw here is pi by 6 to the right, I'm going to draw vertical asymptotes, you know, like this. So these vertical asymptotes are zeros shifted pi by 6 to the right. Okay. When you do it on the graph paper, you probably will get very good result and a very accurate one. And you can also find the image points and then do it, right? So what we have here is, this point is actually pi by 6. Do you see that? And all these points are pi by 6 to the right. That means, oh, okay, these are all minus values. Yes. So that point will be minus pi by 2 plus pi by 6. Do you get the idea? So that means when you multiply this by 3, minus 3 pi plus 1 will give you minus 2 pi by 6 or pi by 3. Is it okay? So this will be at pi by 3, minus pi by 3. Anyway, we will write the equation for these vertical asymptotes just now. Don't worry about it. So what we get here is the vertical asymptotes. Let me write down on this side since it is blank. Now vertical asymptotes for cosecant x. So we are now working on y equals to 1 over, y equals to 1 over sine, or let me write y equals to cosecant all this, minus 2 theta plus pi by 3, okay? Now here, the vertical asymptotes, as you can see here, will be at theta equals to pi by 6 plus, in our case, since we are interested in 2 pi plus n pi by 2. Now in our case, n is minus 1, minus 2, minus 1, minus 2, minus 3, and minus 4. You get my point, right? So this value, so that these are the vertical asymptotes. So you can do this. So that is to say, or you can add pi by 6 to, so 2 pi minus 3 pi by 2 or minus pi by 2 to get your result, right? So these are the different values. So let's do either way. So the answer will be, so if I take away pi by 2's from pi by 6, basically what I'm trying to do here is, let me do it here, pi by 6 minus, when I say pi by 2, I can say 3 pi by 6, correct? So minus 3 pi by 6. So every time you take away minus 3 pi by 6, you get to the next vertical asymptote, correct? So minus 3 pi by 6 will give you minus 2 pi by 6. So let me write minus 2 pi by 6 first, okay? And then again minus 3 pi by 6 will give you minus 5 pi by 6. Again minus 3 pi by 6 will give you minus 8 pi by 6. And then minus 11 pi by 6. And of course, you can simplify these and write them as pi by 3 minus. And here you can write this as 4 pi by 3 minus. That is fine, but writing that is not also wrong. Perfect. So we got the vertical asymptote for our cosecant function. All this exercise I did only to explain you how to get vertical asymptote, and for that we just need to do reciprocal of sine of that function, correct? Now we will incorporate vertical stretch and vertical translation of 2 units, correct? Now the cosecant function will be, so these peaks, every point is getting shifted by pi by 6 to the right. Do you see that? Okay, so let me first sketch the final sine wave in this case, right? So the final sine wave will be kind of like this. Okay, so we'll just do like this, and this is our final sine wave. Okay, and this ends here, so ends here, right? Okay, so this is the final sine wave for us for the period 0 to 2 pi. So let me write this color as here. This is a good space for us, which is sine minus 2 theta minus pi by 6 bracket close. That is the final sine wave. So we got up to this stage. Now we are going to do reciprocal of that. So once you do reciprocal, then what you really do is you just flip them, right? Reciprocal of 1 is 1, and as you go closer and closer, you are getting to a value which is higher and higher. So you can, when you graph it, you can find the points. For example, reciprocal of half will be 2. So then you can continue drawing this way. So that is your secant function on this side. Do you see that? Okay. So that is your secant function without vertical stretch and compression. So I should say this graph is for cosecant all this. Okay. Now we have to incorporate vertical stretch of vector of 5 and translation of minus 2. So when you multiply by 5, then what happens? 1 times 5 is 5, and then you do minus 2, you get a value of 3. So this point will move up. This is at present at 1. Do you see that? So it moves up to 3. So that means, say this is 1, this is 2, this is 3. So it will move up to 3. Do you get my point? So the top portion will actually be, I'm looking for a different dark color to sketch this. Okay, let me use this color itself. So I'm using the final color for this as this one. So it really moves up to 3 units. So this is how where it starts, and the vertical asymptotes I've already drawn. So this is how my wave cosecant function is going to be, right? Where the local minimum is at 3. Do you see that? And on the lower side, where we have minimum at -1, when you multiply -1 by 5, you get -5. Take away 2 will bring it to -7. Let us say, let me break the scale now. Let us say this is -7 for us, okay, -7 for us. So that is our local maximum. So our cosecant wave will be kind of like this. And that is within the period of 0 to 2 pi for theta. So that is our final wave. So the final wave is y equals to 5 cosecant minus 2 theta plus pi by 3 minus 2 as shown. Do you understand? So as you can see, the range of this is what? Range for this is that y belongs to real numbers. So let me write y belongs to real numbers where y is greater than equal to 3 or y is less than equal to -7. Do you see that? And what is the domain of the function? Domain of the function is that theta belongs to real numbers where theta is not equal to pi by 6 plus or minus, you can say n pi by 2, where n belongs to integers. So in general, that is going to be the domain of this function, and for this you can look into my previous video, okay, another video. I hope with this you understand how to really sketch the given function, and I hope that helps. For accurate results, you can use calculator and few values so that you can get your values and sketch it, right? But more or less, that is the concept. I hope that helps. Thank you and all the best.